Hello and welcome back to another VMK in the game development series. In this VMK we're going to finish up working with the cylinder class, and this time it's going to be a little bit different than what we have done in the past. In this video I'm going to show you how to allow the cylinder to roll on the screen. So I'm going to go through the math involved to calculate everything that is needed so that we can make a cylinder roll on the screen. However, then I'm going to propose a challenge for you, and when we get to that point I'll describe what the challenge is. So there will be some code that I have programmed, but I'm not going to show you how I've done it because I want to see whether you guys are actually following along and learning things. So I've given you a challenge to see if you can reproduce what I've done here in the video. Okay, so let's get started. Inside the initialize, I've gone ahead, cleared everything out, and added the following code. So let's go take a look at what I've done here. We have our light source. I haven't changed very much here. And then we have a second light source. So the first light source here is our headlight, and the second light source is just a general light to help illuminate the scene a little bit more. Then I created a texture loader here to load in the barrel texture that we introduced in the last video. And then I create two materials. One material, which is a pure white material. This is the one that I'm going to be using with the texture so that it's nice and bright. And then I create a second material here, which is sort of a greenish color, and this is the material that I'm going to apply to the ground so that it looks kind of like it's grass or something green. Then under the geometry section, I create two cylinders. The first cylinder is a 20-sided cylinder that has a radius of 0.25 and a height of 0.75. And the second cylinder, it's basically the same thing, however the number of sides is only 3. And because this number is low, instead of using the smooth shading, I set it to false here so that I'm not using smooth shading. And the last geometry that I create here is the ground. This ground geometry is just a square 10 by 10 with 20 divisions in each of the directions. Then down here I create the scene graph structure. So the first thing I do is I create the root transform node, and I save that ID number under UI node ID. Then down below I use this ID number to nest everything else underneath it. So the first thing that I nest is the ground, the node shape that holds the ground, and you see that done here. And I also apply the material, the green material, to that ground. Then I create the first rolling cylinder. So what I do here is I create a transform node, tip the transform onto its side, so by 90 degrees about the x-axis here, and then I offset it just so it's in front of the screen and up a little bit above the ground. So it's you'll remember the radius of the cylinder was 0.25, so I've moved it up by 0.25 so the cylinder is actually sitting on top of the ground. And then underneath this transform, I nest a second transform, and this is the transform that I label here roller. This one we're going to be using inside of our update so that we can make the cylinder roll on the screen. And I'll show you how to do this in a minute. And then the last thing we do is nested underneath this transform, we place our node shape, which contains that cylinder that we're going to be rolling. And we apply a texture and we apply material to that cylinder. Then I create a second cylinder. Basically the same thing. We tip it over onto its side. We name it, this time we name it tumble, and I attach node shape for the second cylinder to that tumbling node transform. So that's basically it inside the initialize. Then inside of the update, here's what we do. We get our delta time from our game engine, and we do some calculations to figure out how far do we want to move the cylinder every frame. And the numbers that I've come up here are kind of random, but not really. Notice I create a variable here called fdir, and I set this equal to 1 initially. So this means that our cylinder is going to be moving in the positive direction, so rolling to the right. Each time through this loop, f moved is calculated to figure out how much to the right is the cylinder going to move. So we take the delta time, we multiply it by 0.75. This is sort of a speed factor to determine how far we move. And then we multiply by the direction to determine whether we're moving to the right or to the left. So So initially this is 1, so we're moving to the right. So f moved gives us the distance that we've moved to the right. We then go and look for the node inside of our scene class called a roller. You'll remember that up inside the initialize we labeled our transform node roller. So when we find that, we cast it to a node transform, and then we update the x position of that transform by the value that was saved here, f moved. If this value for the x is greater than 5, so we've reached the limit of the screen, then we're just going to change the direction of the rolling to -1, and then we're going to roll backwards. When we're rolling backwards, if we go beyond -5, we change the direction one more time, and then we'll be going in the positive direction. So in other words, this cylinder is going to be rolling towards the right. Once it gets to the limit, it's going to turn around and roll towards the left. Going to get to the limit again, turn around, roll to the right again. So it's just going to be going back and forth on the screen. As we're moving the node transform using this translate for the x-coordinate, we also want to rotate the cylinder so it actually looks like it's rolling on the screen, not just sliding along the screen. To make the cylinder look like it's rolling on the screen, what we need to do is move the cylinder in the direction either right or left, but as we do that, we also have to indicate how much to roll the cylinder by. And the rolling has to be in sync with this translation. So to do that, we apply this formula here. F move divided by 0.25 times 180 divided by pi. This value here, pi inverse times 180, is a constant which I've defined inside general math. And you'll notice that this value here, 57.29577 so on, is 180 divided by pi. We use this constant to convert an angle in radians to an angle in degrees. So that's what we do here. We're taking this value, which is an angle defined to us in radians, and multiplying it by this constant to give us an angle defined in degrees. Now, how did I know to use f move divided by 0.25? Let's go into PaintShop Pro, and I'll show you where this came from. Okay, so here's what we have. We have a regular plane that the cylinder is going to be sitting on over here, and what we're going to be doing is we're going to be changing the x-coordinate of this cylinder. So as we're moving the cylinder in the horizontal direction, we need to rotate the cylinder clockwise or counterclockwise to make it look like it's rolling on the screen. Well, we know how much we're going to be translating because that's that f moved value that is being calculated for us. So what we need to do is figure out how much to roll the cylinder for a given amount of translation. And that relationship is given here by r theta equals s. If you look inside any geometry textbook, you'll notice that there's a relationship between the arc length of an arc and the radius and the angle that that arc creates. And the relationship is r theta equals s. So in other words, if we take the radius of an arc, multiply it by an angle in radians, then this value is going to equal the length of the arc that the radius arm inscribes outward. So r theta equals s. We know s because that's how far we're going to be traveling in the x direction. So all we need to do is calculate theta. So theta is going to be equal to s divided by r, and s is already given to us because we've calculated here, and we divided by r, and r for us for the cylinder is 0.25. And I can show you that again right here where we define the geometry. We defined it to have a cylinder of radius 0.25. So going back here, that's where we get this formula here. And now remember, this value here that we calculate is in radians, so we need to convert that to degrees because our OpenGL code is only working in degrees for the transformation nodes. So we have that, and we can then go and run the program and take a look. Notice that the cylinder on the screen moves towards the right and is rolling at the same time. When it reaches the limit, the direction flips and it starts rolling back in the opposite direction. So there we go. Pretty neat, eh? Now, here's the challenge. I've created a second cylinder here with a second transform node and stuff, and I've labeled it tumble. And with this guy, we go and call the find node here for the tumble, and inside of this if statement I've written some code, and the code itself, what it does is it makes the cylinder located behind me tumble. Notice that this cylinder is very crude. It's only a three-sided cylinder, so as it's rolling it sort of bobs up and down, unlike this one on this side, which just moves horizontally, very smooth. It doesn't go up and down because it has a nice resolution. This one here has a very crude resolution, so it's jumping up and down as it's rolling on the screen. Now notice one other thing. If I go into the code and let's see here, where the definitions for the cylinder up above, right now we have a three-sided cylinder. If I change this to a four-sided cylinder, the algorithm still works. And the reason for this is because the algorithm that I implemented, which I'm not showing you, is very general. It's actually quite simple, but you can use it to calculate any sort of tumbling for your cylinder. So if you have a four-sided cylinder, it works. If it has a three-sided cylinder, and so on. We can crank this up to whatever value we want, and the algorithm will still work. Let's do 9 here just to show one more time. So the challenge for you is, see if you can figure out what the algorithm is that I created to make the tumbling cylinder work on the screen. Now, one thing that you may want to use while you're programming this to try to figure out how to make this tumble is you may want to go back inside of the HUD and display values onto the screen so that you can sort of get a better feeling for what's going on. You may want to know, okay, if I'm translating in the horizontal direction, how far have I actually translated? So you can output that to the screen and you can sort of debug your code. However, what I've noticed is that when I was doing that, there's actually a bug in our code. And let me demonstrate where this bug is. Let's do a search for GL blend. And you'll notice one thing really quickly here. We have 6 instances where we use GL blend. We have GL enable, GL blend, GL enable, GL blend, and then we have enable, disable, enable, disable. So can you see what the bug is? Anytime you use GL blend, you should use it in sets. Anytime you enable it, you should disable it. Well, you'll notice here we've enabled it twice, but we haven't disabled it. Whereas here we enable it, we disable it, we enable it, and then we disable it. So these ones here are okay, but these first two are a no-no. And because of this, when you do rendering of text onto the screen, under certain circumstances, when you're using transparent objects, your text may not actually appear correctly on the screen. So let's go ahead and fix this right now so that when you're implementing anything, your text will be able to render on the screen properly. Our GL enable, GL blend for our fonts is defined inside of our print text OpenGL function call. What we're going to do is take this guy and remove him from here. Okay, because when we're rendering text on the screen, we don't want to call GL blend every time we render a different set of text. Instead, we're going to take that GL enable and place it inside of our scene HUD. By placing it outside here, we enable GL blend once. We're going to call our print text functions here, which will go print the text, and then once we're done, we can go and call GL disable GL blend. So that'll fix this one guy. The other guy here, GL enable GL blend, this one is being called inside of our node shape. Well, we don't need to call it inside here anymore because we'll handle it a different way as well. So let's take this guy out. And we'll just do a quick scroll through, make sure there's no other GL stuff in here, which, oh, I guess there isn't because it would have been found here. So we can save that. And now this GL enable GL blend, we can handle it inside of a different function. And the location for that is back inside of our render, or it's our update actually. Inside here, we go and call the render. So we're going to be calling render OpenGL for the first pass, and then for the second pass we call GL enable GL blend. We do all this transformation stuff, and then we call GL disable for GL blend here. So this GL blend takes care of all the blending that needs to happen for the second pass, so we don't need to do any additional blending calls inside of our node shape. So let's go and save this, build it, and okay, so now still running, but now if we were to use the HUD, let's go and just quickly print something to the screen, maybe the frames per second. Now you don't have to worry about the text not being displayed on the screen. Oh, we get an error here, invalid font ID. Oh. If you ever get this problem where you get into sort of an infinite loop, you're going to have to break out of your program, stop it manually, and now you can go ahead and correct your code. The reason why we're getting that is because inside of our initialize, or I guess let's take a look at our HUD here. Inside of our HUD, we've specified to use font ID number 3, but inside of our initialize, we probably haven't loaded font ID number 3. Let's see, what fonts did we load? Looks like we haven't loaded any. There's your problem there. So if you want to be able to use the fonts, make sure you go ahead and load a texture font first, and then you can go back inside of the HUD and specify the font ID number here for whichever font you want it to use. So I'm just going to comment that out for now because I don't have a font loaded inside of initialize. Okay, so I hope this challenge is fun, and if you have any questions or if you get stuck, feel free to go to the website underneath the community section, and you can go inside of the cylinder section, which is here, cylinder geometry, and post any questions you may have if you get stuck on something that you're not quite sure about.